So we learned a new shape today. This is like a little known shape. I feel like everybody knows square, everybody knows rectangle, even parallelogram, but people forget about rhombus. Do you know what a rhombus is? A rhombus is a parallelogram with, do you know what it has? 4 equal sides. Parallelogram with 4 equal sides. So you see this one has 3, 3, 3, 3. So it's a parallelogram, all the sides are equal. That's all. But once you get the equal sides, you kind of get some extra stuff. But first let's do the regular stuff. Because it's a parallelogram, the opposite sides are congruent. Obviously, because all the sides are congruent. The opposite angles are congruent. So maybe we'll do like a 100, 100 for there. The consecutive angles are supplementary. So if I subtract from 180, I would get like 80, 80. And the diagonals would still bisect each other. So I didn't draw that in. I guess I could draw it in. You don't have to draw it in, but if I drew it in, it would do like something like that, like you see in the next picture. But because a rhombus is like special, it has some extra special properties. 2 of them actually. The diagonals of a rhombus bisect the corner angles. Bisect the corner angles. So what that means is that these 2 little guys are equal and those 2 little guys are equal. Similarly, on the other side, those many angles would be equal, those many angles would be equal. And we'll do an example of that in a second. The last thing is that the diagonals of a rhombus are perpendicular. And you'll see why when we do the example, but these are right angle symbols that I'm putting inside there. It's all 90s on the inside. So let's look at an example so we can actually see. So I actually split up like a simpler one and then a more complex one. So the first one is our simple example. First of all, I'm going to go around the outside and see all the sides are 8. 8, 8, 8, 8, 8, right? Because all the sides of a rhombus are equal. Then, just like in any parallelogram, the opposite angles are equal, 55 and 55. And if I subtract 180 minus 55, I'm going to get 125, and that goes for those 2 angles. 125, 125. So it's really just a parallelogram at that point with all equal sides, right? Where you start to see those extra rhombus properties is in here. So before I even look at the questions, I'm going to fill in some things I know. The rule that the diagonals bisect the corner angles, that's going to give me all those mini 55s. So angle 1 is 55, angle 2 is 55. Here's where it can get a little tricky. What would the big angle be then if they're each mini ones are 55? Well, 55 plus 55 is 110. So you see again, I'm taking my own advice, redrawing the rhombus blank, and now I can see like this question here, ADC, that's talking about the big 110. DCB, oh wait, DCB, how many degrees would that be? Well, 180 minus 110, 70. Well, if that's 70, what happens when I draw a diagonal in? You're right, it's going to split it right in half. So angles 3 and 4 and 5 and 6 are going to be 70 divided by 2, or 35. And then the last one, oops, I think I did that wrong. Angle 3 is not 35. It's just 4, 5, and 6. The last one is the angle in the middle, which we wrote the rule over here. Diagonals of rhombus are perpendicular in the middle, so angle 3 is actually 90. And like I said, we always have this check of triangles adding up to 180. So if I look here, every triangle here has a 90 and a 35 and a 55, and if I add those up, sure enough, 180. So just like kind of a double check. So this is our shape of rhombus, same as parallelogram, but just a little extra.